everybody. The motivation for this video, which is called Timing Comparisons, is to show you a very important and fundamental property of sets, and that's the fact that it's very, very fast to search a set compared to searching a tuple or a list. So we're going to see an example of that today. But first thing is, let's actually create some of our data types, so like our ranges or our lists. And we want them to have enough elements, because if we're just searching for like a list or a set or anything with like a few elements, that's not going to take very long. So it's going to be more impressive if we have a lot more elements, right? So let's say I wanted to have 10 to the 7 elements. Well, I could type 1 followed by 7 zeros. But instead of doing that, like we're used to in MATLAB, I want to do something like 10 to the power of 7. Now, in MATLAB, we couldn't just use the caret. Most of the time we needed the dot. And we'll see in Python that we're going to have to be a little bit careful when we're exponentiating as well. So if I return this, well, I get 1, 3. And I don't know about you, but that seems a little bit too small to be 10 to the 7, right? So how do we actually get 10 to the 7? Is we do 10, and then the exponentiation is 2 stars and then 7. So now we get 10 to the 7. So don't worry about this operation here. It's not going to be very useful for us. It might come up later, but we'll see. Or if you want to chat about it in office hours, that's fine. But for now, let's just know that if I want to raise things to powers, I use 2 stars. And now let's make a range object. I'm going to call it R. Let's start at 0 and have 10 to the 7 elements, or kind of don't go past 10 to the 7, don't include it either. And let's count by 5. So, okay, there's our range object. Oops, and what did I do? I included a caret. So, okay, perfect, there's a range. Let's use the technique we used in the previous video of converting between data types. So let's take my list, and we'll make a list out of R. My tuple will be a tuple out of R. My set will be a set out of R. So I can evaluate this, and no errors, so looking good so far. And the way that we can check if an element is in one of these data types is I can say, for instance, is 0, and then use the keyword in my list, and I get true. Yes, 0 is included. I can say is 1 in my list, and I get false. So okay, that's looking pretty good. So now let's actually talk about timing in Python. So we're going to use what's called a Jupyter magic. So this is kind of native to Jupyter. It's not a built-in Python thing. This is kind of, it works because we're in Jupyter. So I do 2% symbols, and then I can use the word time it. And what this does is it's going to run the code in this cell a bunch of times, just so it can get a good idea of how long it takes on average. And then it's going to return to me, well, how long did it take the code in the cell? So let's time it, and let's say 0 in my list, so same as before, and we'll wait. And the way you want to read this is, I typically just ignore this part here. It's basically telling you how many times did it run it, kind of what's the average standard deviation. But the main point for us is this 35.5, and then ns means nanoseconds, so that's 10 to the negative 9. So pretty fast. Let's try it again with my tuple. So I can say time it. Let's do 0 in my tuple. We can see here about the same amount of time, so 35.6 nanoseconds. And let's try it now with my set. So I'll do time it, 0 in my set. And you might be surprised here, because I told you that searching in my set is going to be a lot faster, right? So here we have 38.1 nanoseconds, but that's slightly larger than list and tuple. So you might think, okay, well, something's wrong with what I told you. Is set really that fast? And the answer is going to be yes. Kind of what's happening here is that 0 just happens to be the first element in this list, and it's also not just the list, but kind of the first element. It's also included in all of them. But now let's check for something that's not in any of these kind of data types. So 1, namely, remember, because the range, it starts as 0, but it's counting by 5. So let's now do the same thing, but with 1 instead. So let's do time it. Let's do 1 in my list. And now we can see here, it's 24.5 milliseconds, so by 10 to the negative 3. And you can see here it only did 10 loops versus in this original case. So okay, let's do the same thing for tuple. So time it. Let's do 1 in my tuple. And about the same, so 21.1 milliseconds. And now let's try it for set. And we can see here 39.9 nanoseconds. So almost exactly the same as checking 0. So 0 was in my tuple and 1 was not. So kind of hopefully here we can appreciate just how fast it is to search a set. Another thing to keep in mind or kind of to point out is that searching or checking keys in a dictionary is also very fast. And the reason for this is the fact that we're not allowed to have lists in sets, and we're not allowed to have lists as keys in dictionaries. So it goes back to this fact that lists are not hashable, so we can't include them in these contexts. So thanks for watching. Again, main takeaway is that searching a set is very fast, and I will see you in our next video.